Hi, I'm Campbell Thompson, and this is my presentation for the theater project I did. So, number one, proposal slash constraints. So, the proposal was to make a contraption type prop where an axe chops up and down um, on wood. It didn't have to actually chop the wood, but just as show. And it had to have some type of motion, so we had to make the axe move in some way. And it was for Maurice's machine from The Beauty and the Beast. So that's kind of what it looks like up there on the left. And then constraints. So our assembly had to be small in order for it to fit and for them to be able to cover it to still look like a machine or whatever, however they wanted it to look. And then it had to be turned off and on, obviously. For when they needed it, they could just turn it on, have it chop, and then turn it off when they're done with it. And then it also had to be strong enough to push the axe. So whatever we made had to be strong enough to push like a prop axe up and down in order to make it chop. And then it also couldn't be too heavy because if we had some type of heavy machinery, they wouldn't be able to push it. And it was on a cart, so it had to be pushed around. All right, and then part two, planning. So we had some failed ideas, like every project. Our first idea was to use um, an RC drivetrain in order to spin a gear that makes the axe go up and down. And I had designed this little rough idea of what we were going to use. Um, so yeah, that's like what the drivetrain looks like on the left, and we were just going to use like a motor into a gearbox in order to um, push it. And we were planning on 3D printing this whole bracket and everything. But we changed our ideas. Mr. Swift suggested we could use a drill instead of something more complicated. And I designed this obtuse gear on Fusion 360 in order to um, push the axe up as it spins and then let it drop back down like it's chopping. And so the plan was to insert that into the drill and then just have the drill spin. And the one we had was able to lock into place so you could flip the power strip and it was able to stay on instead of um, having to hold the trigger at all times. And then just to brace it down onto a platform using wall bracing, this like metal stuff here, um, just drilling it down into some wood uh, to keep it steady. And then implementation. So our final parts that we needed were, of course, the drill. Mr. Swift 3D printed the gear for us that went into the drill bit. We had a wood platform we had to make to hold it above the cart so the gear was able to spin, and then bracing as well. And this is our final build here. We took the drill and we put that gear into it. We braced it onto that wood, and it's on top of the cart there. And we basically left it for them to latch and do however they wanted um, for the rest of the project because that was kind of their um, domain. And that's it. Thank you.